Hello friends, I hope you are fine. In this video, we are going to read chapter 9 of the book Certificate Physical and Human Geography written by Leong. Friends, I would like to tell you that I have already uploaded all the previous chapters on the channel homepage. You can go and check it out. So let us start. The title of the chapter is Lakes. General. Lakes are amongst the most varied features of the earth's surface. They occupy the hollows of the land surface in which water accumulates. They vary tremendously in size, shape, depth, and mode of formation. The tiny ones are no bigger than ponds or pools, but the large ones are so extensive that they merit the name of seas. Example: the Caspian Sea, which is 760 miles long, as much as 3 to 15 feet deep, with a total area of 143,550 square miles, and is bigger than the whole of Malaysia. Lakes may exist temporarily, filling up the small depressions of undulating ground after a heavy shower. But those which are deep and carry more water than could ever be evaporated remain permanent. Most of the lakes in the world are freshwater lakes fed by rivers and with outflowing streams. Example: Lake Geneva, Lake Poyang, and the Great Lakes of North America. In regions of low precipitation and intense evaporation, where there are few rivers strong enough to reach the sea, streams drain to a lock, forming a basin of inland drainage. Because of the intense evaporation, these lakes are saline. For example, the Dead Sea has a salinity salt content of 250 parts per thousand, and the Great Salt Lake of Utah, USA, has a salinity of 220 parts per thousand. But the Black Sea, into which drain many large rivers, has a salinity of less than 17 parts per thousand. Playas or salt lakes are a common feature of deserts. It must be pointed out that lakes are only temporary features of the Earth's crust. They will eventually be eliminated by the double process of draining and silting up. In regions of unreliable rainfall, lakes dry up completely during the dry season. In the hot deserts, lakes disappear altogether by the combined processes of evaporation, percolation, and outflow. Though the process of lake elimination may not be completed within our span of life, it takes place relatively quickly in terms of geological time. Now we are going to read the formation and origin of lakes. The following are the various ways in which lakes can be formed. Each of them is placed in a specific category, though in a few cases the lakes could have been formed by more than one single factor. The first one is lakes formed by earth movement, and the first one is tectonic plates, lakes. Due to the warping, sagging, bending, and fracturing of the earth's crust, tectonic depressions occur. Such depressions give rise to lakes of immense sizes and depths. They include Lake Titicaca, occupying a huge depression in the Intermont Plateau of the Andes, 12,500 feet above sea level, the highest lake in the world, and the Caspian Sea, 143,550 square miles, the largest lake, almost 5 times larger than its nearest rival, Lake Superior. The second one is Rift Valley lakes. Due to faulting, a rift valley is formed by the sinking of land between parallel faults, deep, narrow, and elongated in character. Water collects in these troughs and their floors are often below sea level. The best known example is the East African Rift Valley, which runs through Zambia, Malawi, Tanzania, Kenya, and Ethiopia, and extends along the Red Sea to Israel and Jordan over a total distance of 3,000 miles. It includes such lakes as Lakes Tanganyika, 4,700 feet deep, the world's deepest lake; Malawi, Rudolph Edward Albert, as well as the Dead Sea, 1,286 feet below mean sea level, the world's lowest lake. You can see here the figure number 67. The second one is lakes formed by glaciation, and the first one is cirque lakes or Tans. A glacier on its way down the valley leaves behind circular hollows in the heads of the valleys up in the mountains. Such hollows are the armchair shaped cirques or quarries. The over deepened floors may be filled with water to become cirque lakes. Example: Red Tarn in the English Lake District. Those that occupy glacial troughs are long and deep and are termed Raven lakes. Example: Lake Ullswater. The second one is Kettle lakes. These are depressions in the outward plain left by the melting of masses of stagnant ice. They are irregular because of the uneven morainic surface and are never of any great size or depth. Example, the meres of Shropshire in England and the Kettle Lakes of Orkney in Scotland. The third one is rock hollow lakes. These are formed by ice scoring. When valley glaciers or ice sheets scoop out hollows on the surface, such lakes of glacial origin are abundant in Finland. Indeed, the Finns call their country Suomi, the land of lakes. It is said that there are over 35,000 glacial lakes in Finland. The fourth one is lakes due to morainic damming of valleys. Valley glaciers often deposit morainic debris across the valley so that lakes are formed. When water accumulates behind the barrier, both lateral and terminal moraines are capable of damming valleys. Example, Lank Windermere of the Lake District, England. The fifth one is lakes due to the deposition of glacial drifts. In glaciated lowlands with a predominant drumlin landscape where drainage is poor, there are intervening depressions. These depressions are often waterlogged, forming small lakes like those of County Down in Northern Ireland. The third one is lakes formed by volcanic activity. And the first one in it is crater and caldera lakes. During a volcanic explosion, the top of the cone may be blown off, leaving behind a natural hollow called a crater. This may be enlarged by subsidence into a caldera. These depressions are normally dry, bounded by steep cliffs and roughly circular in shape. In dormant or extinct volcanoes, rain falls straight into the crater or caldera, which has no superficial outlet and forms a crater or caldera lake. The outstanding ones are the crater lake in Oregon, USA, which in fact occupies a caldera, Lake Toba in northern Sumatra, and Lake Avernus near Naples. You can see here the figure number 69. The second one is lava blocked lakes. In volcanic regions, a stream of lava may flow across a valley, become solidified, and thus dam the river, forming a lake. Example, a lava flow blocks the Jordan Valley, forming the Sea of Galilee, which is an inland lake rather elongated in shape. The third one is lakes due to subsidence of a volcanic land surface. The crust of a hollow lava flow may collapse. The subsidence leaves behind a wide and shallow depression in which a lake may form. Example, Mývatn of Iceland. The fourth one is lakes formed by erosion. And the first one in it is karst lakes. The solvent action of rainwater on limestone carves out solution hollows. When these become clogged with debris, lakes may form in them. The collapse of limestone roofs of underground caverns may result in the exposure of long, narrow lakes that were once underground. Example, the Lac de Silenox in the Jura Mountains. The large depressions called polges, which normally do not have surface outlets, may contain lakes. During wet periods, these may cover most of the polge floor, but they shrink during dry periods due to seepage. An example is Lake Scutari in Yugoslavia. Solution is important in other rocks such as rock salt. Local subsidence may occur when the underlying beds of rock salt are gradually removed in solution. Many of the meres of Cheshire, England were probably caused by this and are also the result of salt mining operations. The second one is wind deflated lakes. The deflating action of winds in deserts creates hollows. These may reach a groundwater which seeps out, forming small shallow lakes. Excessive evaporation causes these to become salt lakes and playas. These are found in the Qattara Depression in Egypt and the Great Basin of Utah, USA. The fifth one is lakes formed by deposition. And the first one in it is lakes due to river deposits. A river may shorten its course during a flood by cutting across its meandering loops, leaving behind a horseshoe-shaped channel as an oxbow lake. Example, those that occur on the floodplains of lower Mississippi, USA and Rio Grande, Mexico. The second one is lakes due to marine deposits. The action of winds and waves may isolate lagoons along coasts by building spits or bars. As these lagoons of shallow water are enclosed only by a narrow spit of land comprising mud, sand and shingle, they may drain away at low tide. They are commonly found off the deltas of large rivers such as the Nile and the Ganges. In East Germany and Poland, lagoons are called haps. Strong on shore winds are capable of pushing coastal sand dunes landwards, and these may enclose marshy lagoons. This type of lagoon is well developed in the Landes of southwest France. The third one is lakes due to landslides, screes, and avalanches. Lakes formed by these processes are also known as barrier lakes. Landslides or screes may block valleys so that rivers are dammed. Such lakes are short lived because the luge fragments that pile across the valleys will soon give away under the pressure of water. When they suddenly give way, the dammed water rushes down, causing floods. Examples of lakes of this type are Lake Gormire in Yorkshire, blocked by landslides. Fafayanon Fretch on Snowdon blocked by screes. The sixth one is lakes formed by human and biological activities. And the first one in it is man made lakes. Besides the natural lakes, man has now created artificial lakes by erecting a concrete dam across a river valley so that the river water can be kept back to form reservoirs. Among such man-made lakes, the most imposing is Lake Mead above the Hoover Dam on the Colorado River, USA. The second one is lakes made by animals. Animals like beavers and particularly interesting. They live in communities and construct dams across the rivers with timber. Such beaver dams are quite permanent and are found in North America. Example, Beaver Lake in Yellowstone National Park, USA. And the third one is other types of lakes. These include ornamental lakes, especially made to attract tourists. Example, Lake Gardens, Kuala Lumpur, Taiping Lakes. Man's mining activities, example, tin mining in West Malaysia, have created numerous lakes. Inland fish culture has necessitated the creation of many fishing lakes. Now we are going to read lakes and man. A careful examination of the lakes of the world will reveal their immense human significance. In countries where they are found in abundance, such as Finland, Canada, USA, Sweden, and the East African states, lakes, together with other inland waterways, have played a dominant role in the human economic, social, and cultural life of the people. The pattern of settlement, commerce, and communication is very closely related to the distribution of the water features. The following are the major usages of lakes and their associated human activities. The first one is means of communication. Large lakes like the Great Lakes of North America provide a cheap and convenient form of transport for heavy and bulky goods such as coal, iron, machinery, grains, and timber. The Great Lakes St. Lawrence waterways penetrate more than 1700 miles into the interior. They are thus used as the chief arteries of commerce. It is estimated that the annual tonnage passing through the Sault Ste. Marie Canal or the Sioux Canal between Lake Huron and Lake Superior is greater than the combined annual tonnage of the Suez and Panama canals. The second one is economic and industrial development. Early settlements and town sites were very much influenced by the presence of lakes. Lakes are an even more decisive factor when they are drained by large rivers with outlets to sea. The Great Lakes St. Lawrence waterways were responsible for the development of the interior wheat farms and lakeside industries. Raw materials, minerals, and fuels were economically handled and assembled in the Holmes district, Lakes Huron, Ontario, Michigan, Erie, and Superior, which has since become one of the greatest industrial districts of the world. Similarly, Lakes Poyang, Tung Ting, and other lakes of the central Yangtze Basin have greatly assisted in the commercial and industrial development of Wuhan, Wuchang, Hanyang, and Hankou. The third one is water storage. Lakes of either natural or artificial origin are vital sources of domestic water supply to surrounding towns and industrial cities. For example, in Britain, Lake Thermere supplies water to Manchester, Loch Katrine to Glasgow, Lake Vyrnwy in Wales to Liverpool, the Okla Reservoir supplies Delhi, and the Vetarna, Bihar, and Tulsi Lake supply Bombay. The fourth one is hydroelectric power generation. In mountainous districts, lakes or man-made reservoirs are used to furnish a good head of water to generate hydroelectric power. Natural lakes are preferred to artificial reservoirs because the volume of water that flows from them varies very little throughout the year. For instance, the Niagara River flowing from Lake Erie to Lake Ontario has a very regular supply of water for its power stations, whereas the Catawba River in the Carolinas, which does not flow from a lake, has very little water during the dry season. Cotton mills have been forced to close down during the period of drought due to insufficient power supplies to run the mills. The Aswan Dam on the Nile in Egypt and the Lloyd Barrage on the Indus at Sukkur suffer from similar defects. The Abu Bakr Dam of the Cameron Highlands supplies much hydroelectricity for central west Malaysia. The fifth one is agricultural purposes. As mentioned earlier, most lakes will eventually be eliminated, and when they dry up, their former beds are covered with thick layers of fertile alluvium. They make excellent agricultural land like the fertile Vale of Pickering in Yorkshire or the rich Red River Valley of Canada, which was in fact the former site of Lake Agassiz. Modern multi-purpose dams, besides generating hydroelectric power, also supply water for irrigation. Example: the Sennar Dam on the Blue Nile in Sudan, the Burinjak Dam on the Murmur Biji on Australia, and the Hirakund Dam, Madhya Pradesh, on the Mahanadi in India. The sixth one is regulating river flows. A river with large lakes in its basin seldom experiences serious floods or lack of water. By absorbing the excess water during heavy rain, a lake reduces the effects of serious flooding downstream. In the dry season, it releases its water so that a steady flow of the river is maintained. Because lakes retain part of the sediment load, rivers, living texts, have clearer water. Lakes that have such functions include the Poyang and Tungting on the Yangtze Kiang, Tole Sap on the tributary of the Mekong, and Lake Constance on the upper Rhine, where such lakes are not available, and flooding is a serious problem. Artificial reservoirs are constructed. Example: the Hoover Dam on the river Colorado and the Bhakra and Nangal dams on the Satluj in India. The seventh one is moderation of climate. Large and deep lakes which are heated more slowly than the land by day and cooled more slowly than the land by night exercise an appreciable effect in moderating the climate of the region in the same way as oceans affect adjoining land masses. Water in the lakes cools the air in summer by absorbing part of the heat and warms it in winter by releasing the heat. For example, the eastern shores of Lakes Erie, Ontario and Huron have a much milder winter than those of the west because the oncoming breezes are warmed by early frosts are minimized. This part of the lake peninsula is therefore important for grapes and fruit farming. Large lakes like Lake Michigan and the Caspian Sea also exert a slight influence on the cloudiness and precipitation of the region. Their large expanse of water acts almost like part of the ocean and helps to precipitate atmospheric moisture into rain. The leeward side of Lake Michigan records a little more precipitation than the windward side. Though the actual amount is often not easily noticeable, small lakes have practically no effect at all on either temperature or rainfall. The eighth one is source of food. Many large lakes have important supplies of protein food in the form of fresh water fish. Sturgeon is commercially caught in the Caspian Sea, salmon and sea trout in the Great Lakes, and in Tonle Sap in Cambodia. Fishing is a leading occupation. Amateur fishermen have found fishing in lakes and rivers a most rewarding pastime. In many countries, artificial lakes have been created for inland fish breeding. This is particularly important in China and Japan. The ninth one is source of minerals. Salt lakes provide valuable rock salts in the Dead Sea. The highly saline water is being evaporated and produces common salt, almost indispensable for human well-being. Borax is mined in the salt lakes of the Mojave Desert. Gypsum is mined in Cheshire and Stassfurt, a small distance from Berlin, is so rich in potash and other chemical deposits that they have given rise to a wide range of chemical industries. In both these areas, the salts are obtained from deposits formed in an earlier geological period. The 10th one is tourist attraction and health resorts. Some of the world's best frequented holiday and health resorts are located on lake sites, for example, Lake Geneva, Lake Lucerne, Lake Lugano, Lake Como, Lake Placid, New York, Lake Vanner, and Lake Vätter, Sweden, the English Lake District, and the Taiping Lakes. The glacier-formed lakes of the Alps have made the tourist industry a national occupation of the Swiss. With this, our chapter ends. In the next video, we will read chapter number 10.